Hello, here's some homework help for Unit 5, Lesson 4, Tables, Equations, and Graphs of Functions. We're starting out here with problem number 1, Part A. Let's get rid of that. Let's slide it up. The graph and the table show high temperatures in a city over a 10-day period. Notice the number of days is on the x-axis. High temperature in Fahrenheit is on the y-axis. Those also coordinate right here with the table, x and y. Input for the days, output for the temperatures. And it says, what was the high temperature on day 7? Day 7, we can look at either the graph right here, or we can look right here at day 7, and we can see what that high temperature was. Do not include the units in Fahrenheit or the degrees in Fahrenheit in your answer. Just give a number right there. On which days was the high temperature 61 degrees? So we need to go back and look through here. We can either look at the graph and look right along here at each of these pieces, wherever we see 61, or we look at each of these and see which one or which days do we see 61 degrees. And we go ahead and put those numbers right here. Click the days that apply. Is the high temperature a function of the day? Explain how you know. Remember that that a function of means is it dependent on the day. In this case, I would make some arguments about this, about climate. I would give that about seasons, but I want you to think about this mathematically. Is the temperature a function of the day? Meaning, is this a function? Yes or no? And what I want you to remember about functions is that the input value has to have a unique output. On each of these, I don't see any inputs right here that are repeated. And because I don't see any inputs that are repeated, I know this is a function. Even though I see 61 degrees on any amount of days, each day has its own unique temperature. Even though it's repeated a couple times, it's still its own unique temperature, or it's its own unique day, meaning that the temperature doesn't matter because it has its own unique output. So is this a function? Yes. Is the day a function of the high temperature? Yes. Explain how you know, then write it out. Problem 2. The amount Lynn's sister earns at her part-time job is proportional to the number of hours she works. She earns $9.60 per hour. This is super key to this. It's proportional to the number of hours she works, meaning that she starts out with 0 hours. She makes $0. That means she doesn't have any savings. She doesn't get any bonuses. She doesn't have anything out there. She just has $9.60 per hour. So on your equation, technically it would end with plus 0, but we actually wouldn't write that in there when we submit our response right here. All I need to see is the expression that represents that she's making $9.60 per hour. Part B is y a function of x, meaning is the amount of money that she makes a function of x, the amount of hours that she works. Is the amount of money dependent on the amount of hours that she works? The answer is absolutely yes. And so we need to make sure that we understand that piece about why that works out. Yes. And then write an equation describing x as a function of y. What we want with part C is give it a try. You can go ahead and write this. The function of x, f of x. I don't know for sure if that's going to show up as a correct answer, but if I see that, I think that'll be kind of cool. And I think that'd be a neat deal to put in there, but the f of x is going to be equal to whatever you came up with as your expression right up here in part A. So make sure you're clear and careful with that piece. We can skip over number 3 and go here to number 4, where you need to solve this system. I'm going to continue to put these on here because we need to talk about the value of substitution. When we look at these two equations, we see that both equations are equal to y. That means that both equations would have the exact same value for y. The question is asking solve the system of equations. That means we're asking, when will these two lines intersect? When will the x value be exactly the same? When will the y value be exactly the same? Since they both equal to y, I can substitute the expression right here for this y. And I know that 7x plus 10, 7 times x plus 10, is equal to negative 4 times x minus 23. And the reason I can say that, again, I'll keep saying that, is because both of these expressions here on the right, Think about it like this. Both of these expressions on the right have the exact same value. If I went ahead and switched it around, it's still going to say y equals 7x plus 10, meaning that the y coordinate is equal to the y coordinate when the value of x is equal to each other on both sides. So solve for x, then solve for y. Put your answer right here as an ordered pair. Don't forget the parentheses, because if you forget the parentheses, it is wrong. I believe that's it for today. Thanks for checking in. Thanks for your work. Let me know what I can do to help.